So here we are, and welcome back to my crazy electronics project. This is a new board delivered by PCBWay. As you can see, it's actually quite a lot different to my usual creations, which use through-hole components. This is obviously using surface mount technology, or surface mount devices if you like. The board looks nice and neat and well put together. Actually, each of these ICs, if I zoom in a little bit here, you might just about be able to see near each IC's pin 1 there's a little SDC capacitor right here. It's so tiny that I can almost not see them with the naked eye. This board, when comparing it to the previous through-hole version with this hacky bodge fix for the timing differences, you can see that actually, even though this board contains better designed logic, it's actually smaller than this board, and it weighs significantly less than the through-hole variation of this board. So all I need to do now is to solder in some of the through-hole headers here, so I can plug it into the rest of the board stack, probably the APU board, and then just to test this one, I might also add in, well, I don't need to actually, because the backplane itself has got an LED and everything, so I'm not going to even bother to solder in the resistor here and the LED here. Actually, I didn't really need to get this one soldered in either, because the power is not coming in through here anymore. But it is what it is. And this board can be used in standalone configuration, or it can be used in conjunction with the APU. I'm going to use it in the APU. So anyway, solder up this and then test it to see if it works. So thank you very much to PCBWay for providing this very neat and very well soldered surface mount board. I'm very happy. It was a very quick and painless process, relatively speaking, to get my usual tooling to produce this surface mount board, so I can't wait to test it really. Hopefully it's all going to work as well as the through-hole version works. In fact, better. I hope it works better. So here we are with a very short video update. I've been testing this board and it didn't work when it arrived, and the reason why it didn't work is because I'm a big dumbo. So the PC2 signal from the Commodore 64, which comes in via the user port via this connector here, is the signal which says the Commodore 64 has written a byte to the user port. And of course this signal, I don't know how it happened, I had a typo or something like that, but basically the signal from the header wasn't reaching the _PC net for all the rest of the schematic and the layout. So here is the bodge wire. The bodge wire connects _PC with what was called _PC2 on the header. So hopefully this is going to work. I've just tested the continuity with my trusty old meter and everything seems to be okay. Everything else seems to be okay. I actually got some of these very small little, you can see it here if I bring them in, very small little micro grabbers. Oops, let me go and see if I can actually see it. They are extremely tiny, but yeah, these little micro grabbers here, I actually use them to test all of the, to test some of the SMT logic with my logic analyzer. It's not focusing on that, that's not a surprise. Anyway, so you can see that they are small enough to grab on each of the individual pads here for these ones. This one is a little bit too tiny. Anyway, so let's plug it in and test it and see if it works. Should do. So here we are, a very short video update about the new user port interface board with the SMT IC here. It's all plugged in into the APU, and my trusty old Commodore 64 is happily running the same shadow reset. So if I reset Commodore 64 and then restart it again, we get the old kind of like loading screen, and then there we go. So at least I know that the new board with these SMT ICs are working properly now. Once I figured out that _PC wasn't getting any signal. So that's all cool. So I'm very happy with that. If I press fire, bing, loading, and then here we go. There we go. Running around left and right. The audio is working as well. I've currently got my small little earbuds here, so I don't know where the microphone is on my phone, but yeah, the audio is still working in the background as well. So all in all, a successful test of using the SMT layout, which is very nice. There we go, 3D visualizer. That's what was built, and this is what is working. So I'm very happy, and I now have more confidence that I can probably change the design over to using this. So that's what I will probably do. I will start changing over designs to use this kind of thing here. This here is not an IC, this here is actually the clock. So it's a little CAN oscillator here instead, but I didn't have the 3D model for the CAN oscillator. It's just using the model for a normal DIP IC.